Properties of solutions. This is chapter 16, section 1. So we have talked about solutions before, and we know that they're homogeneous mixtures. Homogeneous means that they are uniform throughout. We also know that they are aqueous solutions. So when we have aqueous solutions, we know that water is the solvent. And the vast majority of solutions are aqueous. So most solutions are what we call aqueous. Okay, and just to remind you, the difference between a solute and a solvent, because those are two words that we need to know. Solute is what is dissolved. Okay, and the solvent is what does the dissolving. Okay, so if we had salt water, for example, okay, our solute would be the salt and the solvent would be the water. So like sodium chloride, for example, would be dissolved in water. Okay. So there are three factors that affect the rate of solution formation. So how a solution forms. And they are surface area, agitation, so like stirring, and temperature. All right. So for surface area, a smaller particle will dissolve faster. Okay. So one example that I like to use is like individual sugar pieces. So if you just have some sugar and you put that in a cup of tea versus a cube of sugar. Okay. If you are thinking about it dissolving in water or your coffee or your tea, your water can get all in and touch the outside of all these different sugar pieces because there's more surface area, and so all of those particles can dissolve really quickly. But if you have a sugar cube, the water is only surrounding the outside of the cube, which means that all of these particles on the outside have to dissolve first before the inside particles, the particles on the inside. So the sugar cube has less surface area than these individual sugar pieces. With agitation, if we stir, the faster we stir equals, so faster stirring equals faster solution formation. So things will dissolve quicker the faster that we stir, in temperature, right? So if we have higher temps, right, things will dissolve faster. We have faster solutes. Okay, so those are perfect. And it's important to mention that the rate of solution formation, so how fast we make a solution, is different than solubility. Okay, those are different. So solubility, the definition of solubility is how much of a solute can be dissolved in a solvent. Can be. Okay, so whether or not something will dissolve, how much of that. And we have a couple different terms that we use. We have unsaturated solution. An unsaturated solution means that it's capable of dissolving more solute. Okay, so more will go into solution. Okay, in a saturated solution, it has the maximum amount of dissolved solute. Okay. Remember that the solute is what is being dissolved, okay? And the way that we describe solubility, or the way that we express it, is in grams per 100 grams of solvent, okay? Okay, so how many grams of solute can go into 100 grams of solvent? So if salt, for example, has the solubility, so salt has a solubility of 36.2 grams per 100 mils of water, which means that 36.2 grams of NaCl will dissolve in 100 mils of water. And 100 mils of water is the same for water. 100 grams is 100 mils. Okay. Obviously, different salts will have different solubilities. Different compounds will have different solubilities. But solubility is how much of a solute can be dissolved in a solvent. So if something is insoluble, right, it doesn't dissolve at all. Something is soluble, it does dissolve. And this is important about solubility. Okay. So in solutions, and in saturated solutions, which a saturated solution has the maximum amount of dissolved solute, right? This maximum amount, no more can go into the solution, okay? What we say is that that system is in equilibrium, okay? As many formula units, right? When we have an ionic compound, we talk about formula units, that's a representative particle, are dissolving at any instant as are precipitating. So when if the system is saturated, it has the maximum amount of solute that's dissolved in that solvent. Okay, when any more of that compound is dissolving, there is some also precipitating out. Okay, so a good way to think about this is with soccer. So you're only allowed to have a certain number of players on the field at any time. So before person can go onto the field, one person has to come off of the field. And that is exactly the same thing that's happening here. We have this equilibrium, right? So here we have sodium chloride, okay? And as that sodium chloride that's solid, is it's dissolving into sodium ions and chloride ions, right? At the same time, we have this arrow. The arrow is double-headed, okay? Because as the solution is going to create these ions, the sodium and chloride ions, it's also going in reverse when it's saturated in an equilibrium. Okay, and I'm going to write that down about the soccer analogy. Okay. Great. So we can also have what's called a supersaturated solution. When a supersaturated solution is made at a higher temperature, so we can do this if we heat sugar up, or if we heat water up and we add sugar or we add salt, we can add more of the solute and keep that in solution, and we can make a more concentrated solution. So it's more concentrated than normal, and it can be seeded, which means that we drop a crystal in it or another piece of, like, a crystallized piece of salt or sugar, and what will happen is it will cause the whole thing to form. And some of you might have those little they're like heating pads for going skiing or cold weather sports, and they have a little metal disc in them. I have some in the classroom, but of course we're not there. And they're a super saturated solution, and when you clip that little disc, I'll try to show a video of it. When you clip that little disc, it creates a ripple, which creates a surface for crystallization to happen on, and then the whole thing solidifies and gives off a lot of heat. Okay, And this is also how we're going to make rock candy on the stick, is that we're going to make a super saturated solution, and then we're going to seed our skewer, and then it's going to cause the solute to come out of solution and crystallize on the stick. Okay? So there are some factors that affect solubility, which means how much solute can dissolve. Okay? The first is the composition of the solvent and the solute. Okay? Okay, so what I mean by this is which solute is being dissolved in which solvent. Okay, 2 is temperature. Obviously, higher temperatures will increase solubility, how much solute can dissolve, and pressure. Okay. And pressure is only true for gases dissolved in liquids. So for those of you who always like to talk about chemistry in the real world, or when you need to know different concepts from chemistry, most people like soda or sparkling water, beverages like that. So the warmer the temperature is, there is more gas will be released. That's why if you leave like a soda outside on a hot day, and you open it up, more of the gas will be released, versus if that soda is really cold, it'll have more gas in it, because gases can be soluble in liquids. Okay. And what I mean by composition, when I say composition, like, is it water and salt? Is it water and sugar? Is it water and ethanol? Okay, so that's what I mean by which solute and which solvent, right? Salt, water, right? What are you talking about? Okay. So, how does temperature affect solubility? All right. So we just said that increased kinetic energy causes an increase in particle collision. So the reason that solubility increases with an increase in solvent temperature, we have more particles moving around faster. They hit the container, or they hit other particles, and that increases the energy of the collision, which means that things can go into solution easier. So an example is like sugar and water, right? More sugar will dissolve in water at higher temperatures because the particles are moving around, and when they hit the water particles hit the sugar, they will more easily go into solution. Okay. Yeah. So solubility of most solids increases with an increase in solvent temperature. Okay. So there are liquid solutes and solvents. We have miscible and immiscible. Miscible means that they can be mixed, and immiscible means they cannot be mixed. Okay. So water and alcohol are miscible. If we mix them together, they will form a solution. Alcohol and salt water are immiscible. Okay. So another example is oil and water immiscible, water and alcohol are miscible in all proportions, and salt water and alcohol are immiscible. And I normally have a demo, but I will send it to you because I can't do it today, unfortunately. Okay. So this is what I was talking about with the gases. So solubility of gases and liquids. Gas solubility decreases with an increase in solvent temperature. So this is what I was talking about, opening a soda on a hot day. More gas escapes. Okay. gas solubility increases as the pressure of the gas increases, okay? So solubility increases as pressure increases, okay?